Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the subject of CHM421, Analytical Chemistry. In this video, we will continue our learning on the topic 1, units for quantities and concentration. In this video, I will talking about the percentage concentration, ppm, and also ppb. This is another way to express the unit of concentration. Previous video, we talking about the molarity in normality in a way to express the concentration of the solution. So, percentage concentration, because of this percentage, maximum is 100%. So it should be pph is part per 100. So we can have three type of percentage concentration. We can have a percentage weight per weight, percentage weight per volume, or even percentage volume per volume. So it tells the number of parts in 100 parts. So for example, we have a gram of substance A in 100 gram of sample. So this is the formula for the percentage of A. The number part of A divided by the number parts of sample, and then we multiply by 100. So moving forward to the percentage weight per weight for solid sample. Because of this one is a weight per weight, so normally we use this percentage concentration for solid sample. So the percentage weight per weight is a percent weight in a weight concentration. For example, a weight of substance in 100 gram of sample. So in order to calculate weight per weight is a weight of the solute in a gram divided by weight of the sample in a gram times 100. So this is example, 37% weight per weight hydrochloric acid, meaning that this solution is containing of 37 gram of HCl in 100 gram of solution times 100. So 37 gram of HCl will be dissolved in diluted with sufficient water to make 100 gram of solution. So the solution produced will has 37% weight per weight of HCl. So this is the example for the percentage weight per weight. Is given in the slide. 25 gram of potassium chloride is dissolved in water to make 250 ml of solution with a density of 1.14 gram per milliliter. So you have to express the concentration of the solution in percent concentration weight per weight. So you have to express the concentration in percentage weight per weight. So you should have weight of solute and also weight of the solution. So now the solute is potassium chloride, okay, KCl. So the mass is uh, the mass 25 uh, gram. Dissolve in water to make 250 ml of solution, and then so you have to find what is the weight of solution. So now the solution in here, the solution uh, has 1 ml equivalent to 114 gram from the density. So if we have 250 ml of solution, so the mass it should be uh, 250 times 1.14 divided by 1. So the mass is 285 gram. So if you are asking to express the concentration in terms of weight per weight, so the mass of the solute, it should be 25 gram over the mass of solution to 85 gram, and then you can using your calculator 20 25 over 20 285. So 0 point times this one is times 100. So times 100, 8.77%. So 8.77 percent weight per weight. Okay. Okay. Now moving forward to the percentage concentration weight per volume. So because it's per volume, so this unit of concentration normally used for liquid sample. So the percent weight per volume is the percent weight in volume of concentration. So the weight of the solute in 100 ml of sample, for example. So this is the formula that we will use to calculate the percent weight per volume. The weight of solute in a gram and the volume of sample in milligram. Is compared to this one is gram per gram, and then this one is gram per ml. Okay, gram per gram and gram per ml. So example, we have 5% weight per volume of silver nitrate, meaning that 8 gram of silver nitrate in 100 ml of water. Okay. Briefly explain how to prepare the following 1 liter of 10.50% weight per volume of aqueous this chemical. So, uh, how to prepare, meaning that we have to calculate the gram in 1 liter. So, percentage weight per volume is the gram per milliliter. So the volume in this case is uh, 1 liter. So 1 liter is similar to 1000 ml. So the percentage of weight per volume is given. We are asking to calculate the number of uh, gram. So the mass required to prepare this 1 liter of 10.5% weight per weight is the 10.5 divide times 1000 ml, and then yeah, so you can get sorry, just to make sure you're not confused. So 10.5 100 times 1000 ml. So 10 point over 100 times 1000, 105 gram. So you need 105 gram of the chemicals, and then you dilute it using distilled water and 1000 ml of water in the gravimetric glass. Okay, so this is another question. A solution is prepared by dissolving 0.5 gram potassium nitrate in 100 ml volumetric flask and diluting it to the volume. Calculate the concentration of the solution percentage weight per volume. Weight per volume is gram per milliliter. Okay, so it should be 0.500 gram and 100 ml times 100%. So 0.5145 divided by 100 times 100. So 0.5%. Okay, this one weight per volume. Okay, so percentage volume per volume. Of course, volume per volume more to the liquid sample. So percentage volume per volume is percent volume in volume concentration. Volume of the solute in 100 ml of the sample. With percent is volume ml in volume of sample in ml. So we know previously we have percentage weight per weight. It should be gram per gram. And then percentage weight per volume, it should be gram per ml. And now we have percentage volume per volume, it should be ml per ml. Okay, so 5% of aqueous solution, meaning that 5 ml of methanol in 100 ml of solution times 100. Okay. This is example for percentage volume over volume. Boric acid, also call it hydrogen boride, having a chemical formula of H3BO4 in the density of 1.4 gram ml. A boric acid solution was prepared by dissolving 17.9 ml of boric acid in water and then diluted into 500 ml of volumetric glass. So calculate the percentage of percent volume per volume. So volume per volume should be this volume of boric acid 17.9 over volume of solution 500 ml times 100%. So this one is 17.9 over 500 times 100. So 3.85% volume per volume. So, uh, this is the exercise that you should try. Answer is already provided. You can check. Calculate the concentration of solution A when 218 grams of A is dissolved in 6.83 liter. So this one is concentration. You have to calculate the concentration. Is mass over volume. Okay, is gram per liter. Okay, so you have to use this gram and then divide it with this liter. So you can get 218 divided by 6.83. You can get 32. Sorry, 218 divided 6.83. So you get 131.92 gram per liter. So you have to try this one. Okay, this is another example you should try. The concentration of solution B is 12.1 gram per liter. Calculate the width of solute present and 2.23 liter of its solution. So you have to calculate the mass. How many gram present in this 2.23 liter. Okay, so you can see concentration of solution is in 1 liter is equivalent to 12.1 gram. So it's asking you for 2.23 liter is equivalent how many gram. So you can settle X. Okay, you can try. So I just click the calculator. 2.23 times 12.1 and then divided 1 26 9 9 8 gram. So you can try. Okay, also this exercise you should try how many moles of solute. So it's asking you how many mole of solute present in 16.3 liter of solution containing of 0.11 molarity, and this is a molarity is a mole per liter. So uh, from here this similar to 11 gram mole per liter, or 1 liter is equivalent to 0.13 mole. So if you want 16.3 liter, so the X should be how many mole? 16.3 times 0.113 divided 1. So 1.8419 mole. Okay, seems good to this answer. You have to try. Okay, calculate the molar concentration of ethanol. Is a molar concentration. It's asking about molar concentration. In aqueous solution, ethanol in aqueous solution that contain of 2.0 gram of ethanol. This is molar mass of ethanol. This is the volume of the solution. So it's asking you about molar concentration. Molar concentration is molar Lt is mole per liter. Okay, so you have to calculate the mole of the ethanol from the mass of ethanol and the molar mass of the ethanol, and then you divide it by the volume of the solution uh, to get the molarity. Okay, so mole is 2.3 divided 46, and then divided answer divided 3.5, and then you can get 0.043 molarity. So this one is very straightforward. So you can also calculate this one, calculate the molarity. You want to calculate the mole per liter of 15 gram of ammonia in 75 ml solution. So this is ammonia. Yeah. So first you have to calculate the mole. Mole is the mass over molar mass, and then this liter, the volume, it should be converted into liter. 1 liter is 1000 ml. So 750 divided 1000 is 0.575 liter. So you have to try. So the mole is 15 over nitrogen, hydrogen, nitrogen 14 plus 3, 15.0, the answer. So this is the mole number 0.8824, and then divided by liter 0.75, and then you can get the answer 0.1765 molarity. So you have to try this exercise. Okay, all right. So now we are moving forward to the PPT, ppm, and also ppb for solid and liquid. PPT is the part per thousand, ppm is part per million, ppb is part per billion. Part of substance presents in 1 million or 1 billion of the solvent. Normally we use our water as a solvent. If we use a gram is the unit, 1 ppm meaning that we have 1 gram of substance in 1 million gram of solvent. So this is the formula to calculate the PPT, part per thousand. For the solid, it should be weight per weight. This Y is gram over gram times 10 to the power 3. 10 to the power 3 meaning it is 1000. Liquid is weight per volume. It should be gram over ml times 10 to the power 3. Okay. ppm is a part per million. So for the solid, it should be gram per gram times power 6. For the liquid, should be gram per ml 10 to the power 6 for million. ppb, for the solid, it should be mass of solid per mass of sample, gram per gram times 10 to the power 9. because it's a billion. And also for the liquid, it's a gram per ml times 10 to the power 9 is a ppb. Okay, so we have several examples here. A solution is prepared by dissolving 0.5 gram KNO3 in 100 ml volumetric flask and diluting it to the volume. Calculate the concentration of the solution and ppm. ppm is because this one is concentration. Uh, this one is ppm liquid milligram per volume. Okay, so we have this ppm is uh, ppm is gram per milliliter. Gram per milliliter times 10 to the power 6. Okay, so 0.545 gram liter 100 milliliter 10 power of 6. So 0.545 divided by 100 times 1 to the power of 6. So 4,500 ppm. Okay, all right. So now we come to the dilution. Dilution it occurs whenever a solvent is added to the solution. We dilute the original concentration. Adding solvent result in a solution with lower concentration. The concentration of solution following dilution can be calculated using this formula M1 V1 M2 V2, where M is molarity, V is volume, subscript 1 and 2 is referred to the concentrated and also diluted value. During the dilution, you should know what is the difference between stock solution and working solution. Stock solution is a stable solution with non concentration. It prepared at a higher concentration, which later may be used to prepare the solution of lower concentration by dilution. It can be save you time. It can be conserve the material. We can reduce the storage space, and we can improve the accuracy during the working solution are prepared. So a working solution is a solution we made for actual use, for the actual use during the experiment. Usually made up from diluting, or we combining the stock or the standard solution. So, for example, we have a stock solution of 1000 ppm. It can be diluted into a series of concentration uh, into from 100 ppm, 1 ppm, and also 0.1 ppm. So this one we call it a working solution. This one is a stock solution. Okay, so we use the formula of N1, B1, and M2, B2. So how come we can know if we want to prepare 100 ppm from 1000 ppm, use the formula of N1, B1, M1, B1, M1. We want to know how many ml of 1000 ppm used. So M1, we don't know the V1, we want to find out. And then in 100, this one is 100 ml times, sorry, this one is 100 ppm in the 250 ml of volumetric flask, and then we can get V1. So same goes to 100 ppm can be further diluted 1 ppm. Using the same formula, we can know how much uh, uh, volume of 100 ppm needed to prepare to 100 ml of 1 ppm of solution. Okay, so also here you also can prepare 0.1 ppm in 100 volume, so you can calculate what is the volume of 1 ppm is needed to prepare 0.1 ppm of 100 ml of solution. So you just use the similar formula M1 B1 and M2 B2. So explain briefly how to prepare the following solution in the laboratory using PB and O3 is the starting reagent with 250 ml and 220% weight per volume of PB and O3. So 250 ml of 250 ml of 20% weight per volume. So weight per volume meaning that is a gram per milliliter. So gram per milliliter. Okay. See, double check. Milligram per uh, gram per milliliter. Okay. So milligram per milliliter. So gram per milliliter. So uh, from the 20%, meaning that is 20 gram per 100 milliliter or 100 ml is equivalent to 20 gram. So 250 ml, it should be 250 times 20 divided per 100, and then you can 250 times 20 divided by 100, 50 gram. So in order to prepare this solution, we need 50 gram of PbNO3 dissolved in 250 ml of volumetric flask using water is the solvent. All right. So describe the preparation of 1 liter to molarity of ammonium hydroxide from concentrated solution that has purity 25% weight per weight and specific gravity 0.957. So this is the molarity is a mole per liter. So weight per weight meaning that 25 gram and 100 gram of sample. So Molar mass of ammonium hydroxide that can be obtained from the product table is 35 gram ml, gram per mole. So the concentration of 25% weight per weight, meaning that and specific gravity of 0.957 gram per milliliter. So so this concentration is 25 gram and 100 gram. So we want to know the okay. So this one we know the specific gravity of the ammonia is 0.957 gram per mole, meaning that 1 milliliter is 0.957 gram. So uh, we can calculate uh, the molarity. Okay, we can calculate the molarity of 25% weight per weight volume. So molarity is mole per liter. Okay, so we know in this sodium hydroxide, 1 ml is equivalent to 0.957 gram. So we can calculate the mole. 1 ml is 0.95 gram. Okay, uh, 25 over 100 gram is the percentage weight per weight, and then we multiplied by the specific gravity 0.957 gram per milliliter, and then we know the molecular mass is 1 molecular mass of sodium hydroxide is 1 mole 35 gram, and then we convert in liter because we need molarity in liter. So we can cancel each other all the unit, gram per gram, gram per gram, and also mole per mole. So what we can have is mole per liter is equivalent to molarity. So when we calculate using the calculator, so we can get the 6.8357. So now we want to prepare uh, uh, 1 liter. We want to prepare 1 liter of 2 molarity of ammonium from concentrated solution. So the concentrated solution that we calculate just now, what is the molarity? Is the 6.8357 mole per liter. So we need to calculate what is the volume needed. This is why we use M1, V1, and M2, V2. So we know this molarity 6.8357. We want the volume. Sorry, this is one, and then to prepare two molarity volume 1 liter or 1 liter. Okay, so V1 it uh, should be 2 times 1 over 6.8351. So it's 0.2926. 2926 liter, or uh, 0.2926 liter times 1 liter is 1000 ml, is 1000 ml. So it's 292.6 ml. So this is the answers. Okay, similar to here. Okay, so we have to measure the 292.6 ml of concentrated of ammonia and diluted it with distilled water to make 1 liter of volumetric flask with 2 molarity. Okay, so this one you can try, I think. Methanoic acid has a density of 1.22 gram. Describe the preparation of 500 ml, 0.7 molarity without weighing the methanoic acid. So answers is given on this slide. You can have a look, and you can try do the calculation. And the molarity, another question, the molarity of 90% weight per weight of this solution is 12. So you can determine the density, and then you have to describe the preparation of 200 ml solution of 1.5 normality H3PO4. So this one also answers given, and then you can analyze the answers, and then you have to try to answer this question. Okay, molarity and also normality. Okay, so also another question you have to try. Uh, Explain how to prepare 250 ml, 350 ppm of sodium 2 plus from solid magnesium sulfate. So the answers is also given, and then you can have try. Okay, same to the other question as well. Other question as well. Okay, so I leave it you to try all the exercise given on this slide. Please refer the answers provided. But if you have any problem regarding the question, you can ask during our online lecture. Okay, I think thank you very much. See you again on the next video. Assalamualaikum warahmatullahi wabarakatuh. See you again. Okay, bye bye.